You're watching Definitive Diagnosis. Don't forget to subscribe. Thanks for watching. Okay, so here we have the can high. Here we have the can low. We're measuring in the back of the DLC. That's what it's reading at the moment. I've got the markers on there. You can see 2.5 volts on low and high. Okay, I've got the scale set to 14 volts and we're going to do short to positive first. Let's see what happens. That's our battery voltage. This one, we're going to go with can high first. So there we go. Now let's go short to positive on can low. And that one is still seeing a slight signal. So if ever you see that, that's short to positive on can low. Okay, so next we're going to do short to ground. Same scale on the scope. Got a good signal. So there's our battery voltage. Now we're going to go, let's go can high first. So that's pulled both to ground. A slight bit coming through here and there. Back to our good signal. And now we'll go can low. Whoa. That's short to ground on can low. So the can high signal is, yeah, that's interesting. Okay, so good signal again. Now we're going to do open circuit on can high. Just pull that apart. Okay. I just need to stop this and we can have a closer look. Okay. So that's open circuit on the can high. And same again, this time we're going to go open circuit on the can low. Kind of the opposite of what we just had. Just stop that. Skip that back. There we go. So if ever you're getting that, there's open circuit on can low. So this time we're going to short the can high and can low together. Let's see what happens. There's a good signal. So let's see if I can get that in. There we go. That's the multimeter switching off. 2.5 volts. with that. Can high and can low, disconnect, back to normal. Okay, so this one we are going to look at the terminating resistors. At the moment we're back probed into the DLC and we have our 63 ohms, so that's 120 ohms in the CIM, and then we've got 120 ohm resistor in the ECU. So one of the questions I was asked by a good friend of mine, Danny, can we bypass that with a resistance box? So this is the schematic. Here is the DLC, so that goes into the CIM. The wires that I've got here, the CAN wires, that's where I've cut between the CIM and the ECU. So we've got 120 ohm resistor here and another one here, which is why we're getting our 60 ohms. So if we take the ECU out and pop in 120 ohms via the resistance box, are we still going to see that? Let's find out. Okay, so that's off to the CIM, and now we have 125 ohms. So it's just connecting up the resistance box. There you go. Turn that off. There we go. It can be done. So now we're going to add resistance to the CAN high. We're in series on the CAN high line here. We're going to add some resistance gradually through the decade box. We've currently got our signal there. So I think if you keep your eye as we go up through the resistance on this line and this line here, this is where you're going to see the change. So I'm just going to try and keep this steady. Just going to add 10 ohms. Now we're going to add another 20. It's really starting to pull it now. And now we're going to add another 30. If I just switch those off, you'll see the jump. So that was 60 ohms. So if we go just 30 ohms, you see it started to jump quite a bit. And back to normal. So let's go for 100 ohms. Now 300 ohms. Let's add another 300 ohms. So that's what high resistance on the CAN high looks like. So this time in series on the CAN low. So it kind of runs in the opposite. So if we watch, here goes 100 ohms. Another 200 ohms. It seems to go in the opposite direction, which makes sense. So that's high resistance on CAN low. So this one, as requested, was to show what the signal would be like with a poor wiring repair. Now I managed to just get, I'm not sure if I can focus on this, but that's just one strand of the wire on the CAN high, and it's not made a huge difference. So I'm just going to join that back together, and that's it. So it didn't make a massive amount of difference with just one strand. That's enough for that signal not to be affected. So, you know, poor repairs, yeah, it should be done properly, of course, but how much that affects that signal, not a great deal.